Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to finish up with lesson 15, and that will be the last lesson of the year, inshallah. So we were talking about solving inequalities basically, and you learned to solve a number of inequalities in that previous set. So this is going to be the end of it. However, these ones are a little bit tougher, and I'm quite sure you haven't seen all of these in middle school. Okay, so just kind of be prepared for this one, inshallah. Let's start with number 78. All right, number 78 says x minus 1 times x plus 1 multiplied by, is greater than x minus 3 times x plus 4. Now, if you recall, we learned about the a minus b, a plus b formula in lesson number 8. That's going to come in very handy so that we don't need to use the FOIL method, and we can simply say x squared minus 1 on the left side. And on the right side, you'll have x squared, times 4x minus 3x, so plus x and then minus 12. All right. Now, notice how there's an x squared on either side, so it's good enough to just sort of go ahead and cancel those out. So you'll have negative 1 is greater than x minus 12, and at that point you can bring the negative 12 over and make it a positive 12. So you'll have 12 minus 1, which is 11, which is greater than x, and therefore x must be less than 11, right? Remember, it's better to put the x on the left side and the number on the right side, right? And we continue in the same vein of making sure that we know the several methods of graphing our answers and communicating our answers. So one of the ways to communicate your answer is to say x is less than 11, open circle, and then you shade everything to the left of the circle. All right, so let's kind of put that in a different color. So open circle, and then everything to the left of the circle. That's one of the ways to do it. Another way to express this notation is to go ahead and make the same exact graph. I'm just going to do this for the first time. I won't do it for all of them, don't worry. And then make a parenthesis that is facing that way. And then it opens up to the left, basically, and then you do it like that. All right. One of the benefits of using the second notation, even though it's kind of outdated, and you don't see it too much in the textbooks anymore, is then you can say that the the interval notation is negative infinity to 11, and there's a parenthesis at the 11 side. So these are all different ways of expressing the answer, and of course, the inequality way of expressing the answer is right over there. All right, let's keep moving. Number 80 says x multiplied by 9x minus 5. All right, so x multiplied by 9x minus 5 is less than or equal to 3x minus 1 whole squared. All right, so for this one, one of the ways that we can expand 3x minus 1 whole squared is to use the a minus b whole squared formula, which says a squared minus 2ab plus b squared. What is the other way to do it, in case you forget the a minus b whole squared formula, is to just simply go ahead and use the FOIL method, and you'll get to that same exact conclusion. So here's what we'll have. X times 9x is 9x squared. X times negative 5 is negative 5x. On the right side, you'll have a squared, so that's 9x squared, minus 2ab, so 2a and then b, plus b squared, so that's 1 squared, which is still 1. Notice again that the 9x squareds will cross each other off, and you'll end up with negative 5x on the left-hand side. You'll end up with negative 6x and then plus 1. Again, just go ahead and move the negative 6 over. So you'll have 6x minus 5x, which is simply an x, and that is less than or equal to 1. So, simple and done. All right, let's go to number 82. And in number 82, you're going to find something, a technique that we used in the previous set again. So number 82 says that you've got 1/3, let's do it over here. All right, you got 1/3 is less than x plus 1 over 2, like that, and then it's less than or equal to 2/3. All right, so our job is going to be to basically work with these fractions. Now, one of the ways that you can make your life a lot simpler when it comes to these fractions is, remember, you're trying to solve for that middle term, but the fractions are having denominators of 3, 2, and 3. So if you were to use the technique of multiplying by the LCD, recall this is a technique that we established in one of the lessons for solving equations, and what it did is used to eliminate all kinds of fractions. So that would be a very good technique to use right now. So the LCD of 2 and 3 is basically 6. So if we were to multiply by 6 throughout, right, here's what will happen. In that first situation, the 6 and the 3 will cross each other off, and you'll end up with 2 and 1. And then you'll end up with 3 and 1, and then finally you'll end up with 1 and 2, right? So when you have something like that, it's going to save you a little bit more time, because here's what you'll have. You'll have on the left hand side, you'll have 2, then you'll have 3 times x plus 1, and then you'll have less than or equal to 2 times 2, which is 4. Now you can go ahead and expand the inner part of parentheses, so 3x plus 3, 2, and less than or equal to 4. And this is kind of the same as the homework that you guys previously had, is just go ahead and subtract 3 on all sides. So you'll have negative 1, you'll have 3x, and you'll have positive 1. And finally, the last step is to go ahead and divide everything by 3. Right? So when you divide everything by 3, you'll end up with negative 1/3 is less than x is less than or equal to 1/3. Alright, now I just want to remind you that negative 1/3, where is that on the number line? It's between 0 and negative 1, whereas positive 1/3 is between 0 and positive 1. Alright, now number 84 is a very odd question, and this has confused a lot of my students in the past, so let me slow down a little bit for number 84. Number 84 says that 2x minus 1 to the power of negative 1 is greater than 0. So for this, you need to know a little bit about fractions and how they work, right? So let's suppose that I gave you the fraction 6/9, right? And I said, go ahead and simplify that. So you would tell me that 6/9 is equal to 2/3, right? So let me ask you this. Is that the same thing as 9/6 equals 3/2? Yes or no, right? So when I flipped these particular spots, right? So here's that spot right there. I flipped it over, meaning I did its reciprocal. And then here is that top spot that has come to the bottom, right? Is this still true? Is 9/6 still 3/2? And you will say, yes, it's quite true. Well, here's the thing. If I were to tell you that you have 0/5, right? 0/5. What is that equal to? That is equal to 0, right? 0/5 is equal to 0. Well then, if I were to flip 0/5 and make it 5/0, the question is, what does this become? Most people don't know the answer to this, all right? Most people don't. This actually becomes any number divided by 0, right? And if you want to put the number 1, okay, you could say 1 divided by 0. But what do you recall from the lesson on rational expressions and telling domains is this right here is undefined. It's actually undefined, all right? And so we have a bit of a situation here, because when something like this occurs, when one of those numbers is zeros, the rule, yes, it somewhat applies, but it also kind of throws you off, because you really can't tell what the number on the top was first off, right? And so it gets a little bit kind of confusing for students. All right, so what I want to show you now is a technique that we've developed in math to work with this. First off, notice how that says to the power of -1. And if you go back to the lesson on exponentials, anything that has a negative power, you can go ahead and put it to its denominator and it'll take a positive power. Like for instance, if you had x to the power -5, if you want to give it a positive exponent, make it 1 over x to the power +5, and then it has a positive exponent. So therefore, what we could say is 1 over 2x minus 1 is greater than 0. All right? That's one conclusion that we can make. But realize we can't really like flip this thing over necessarily, right? Because if we were to do that, then the right side would become undefined because of what I just explained to you on this side, right? So we need to have a different technique to work with this, right? And the question is, what does it mean when you say greater than 0? What does that even stand for? Like on a number line, if I told you all numbers greater than 0, what does that mean to you? All right, so what it really stands for is positive. All right, anything that is greater than 0 is a positive number. And so really what we're trying to say here is 2x minus 1 is actually a positive number. All right, that's actually the conclusion that we make. So it's very new from what you're accustomed to, and it's not a middle school thing, right? What we're trying to say here is, look, if you've got a positive number and it's divided by something, right, and you're telling me that it's a positive answer. So you've got a positive number and it's divided by something, right, and it's a positive number, right? It's going to give you something that's greater than 0. That means this something must be positive. It can't be a negative result. And so using that logic, 2x minus 1 is greater than 0. So all of that talk for this right here, for you to understand why that occurs, right? And then you just go ahead and you solve it, and you say 2x is greater than 1, so x is greater than a half. So what we're trying to say here is as long as x is a number that's going to be greater than 1/2, as long as you can give me a number that's greater than 1/2, and you can stick that number right over here, all right, right into the x, you're going to assure yourself that the answer will always be positive. Okay, so that's actually how you solve number 84. It's a very unique type of problem, and a lot of students don't necessarily know how to work with that. Speaking of problems that have kind of caught students off guard, number 86 is also yet another such question. Number 86 says 0 is less than 4x. All right, so number 86, 0 is less than 4x is less than 2/3. All right, and remember in that previous lesson I said that's a really unwise way to say something, right? 0 is less than something is less than 2/3. It just doesn't, it doesn't fit. What we're really saying is 4 over x is between 0 and 2/3. Now, let me ask you this. If a number is past 0, like on a number line, if I just told you that I've got a number, okay, I've got some number, and it is definitely past 0, and it's before 2/3, what's one thing that you can assure me of is, well, that must be a positive number, right? Because any number that's after 0, because of something similar I said to you earlier over here, it must be a positive number. And now the fact that it's before 2/3, that just adds more to that, right? So when we are working with this problem, basically the side that we're really working with is the right side. All right, it's again, it's just a unique way of looking at the problem. So we're really working with the right side, because remember, the left side, what it is really trying to explain to you, what it's really trying to tell you, that left side right there is trying to say that if something is greater than 0, then it's going to be positive. All right, it's only the positive results. All right, so it's not necessarily algebra that you're using in that situation. So let's work with that right side first. So 4x is less than 2/3, and therefore you can cross multiply these, and just like if you don't understand why can you cross multiply them, just like if you had 4x equals 2/3, what would you have done? You would have cross multiplied. So the same thing happens here, is you multiply the 4 and the 3 to get 12, the 2 and the x to get 2x, and then you divide on both sides by 2, so you end up with 6 is less than x, right? Now, if you were focusing on that left-hand side of the equation, we had said that you're going to have a positive result, right? It's got to be a positive number. And what that basically means is you already kind of said that, right? Realize that you said x is greater than 6. So the fact that there was all of this mess over here doesn't really change much for us, because as long as x is a number that's greater than 6, it's going to fit that inequality, right? And we're going to just test out some numbers just to convince you, because that one has confused students in the past. So really, when it comes to x and what x could be, right? So this one was for what 4 over x could be. So what x can actually be, x can be any number that is greater than 6. All right, as long as x is a number that's greater than 6, you're good to go. All right, now, it might require some convincing. So let's suppose that x was equal to 10, right? Let's just suppose, just so that you understand that this actually works. Well, how would that inequality look like? It would look like 0 is less than 4 over 10 is less than 2/3, all right? Now, if 0 is less than 4 over 10, that's 0.4, and that's 0.67, right? I'll just round it, right? So notice how that number is truly between 0 and 0.67. Now let's suppose, this is a counter case, but let's suppose x was not greater than 6, right? Let's give a number that's, let's suppose it was 3. All right, so here's what would happen. It would become 0 is less than 4 over 3 is less than 2/3. Now in this case, you end up with 0 is less than 1.33 is less than, and this continues to run, of course, is less than 0.67, and of course we just rounded that 6 to a 7, right? So in this situation, notice how this is untrue, right? That's untrue, and that's why we say that the answer to this question is x has to be a number that is greater than 6. Now, number 88 is very similar. It basically says that 0 on the left side, 3x plus 6 to the power negative 1 in the middle, and then less than 1/3, right? So again, what's the logic? Is really what we're saying is 1 over 3x plus 6, like this over here, is less than 1/3, and all the left side really stands for is it's saying that everything on the right, right, everything over here has to be a positive result. So whatever you get from 1 over 3x plus 6, whatever the answer is, it must be an answer that is between 0 and 1/3. All right. Now, with less logic this time, and just kind of, going through the motions of it. So how do you exactly solve this inequality? Is you're going to go ahead and cross multiply. So the 3 is going to multiply to the 1, and the 3x plus 6 is going to multiply to the 1 on the other side. So it looks like this over here. And then you're going to subtract 6 on both sides, so you'll have negative 3, right? So basically you're moving that 6 over, and 3x like this. Then you divide by 3 on both sides, so you have negative 1 is less than x, all right? Or in other words, x has to be a number that is going to be greater than negative 1. So what we're trying to say here is as long as x is a number that's greater than 1, it seems like this is going to give us the results that we're looking for, right? And you might be thinking, well, what was the use of all this? So just kind of rewind the video and realize that that's more like telling you something than anything else, all right? So let's just make sure this works, all right? So let x equal to negative 0.5. All right, let's just say x was equal to negative 0.5. That is a number that's greater than negative 1, right? Because it's on the right side of negative 1, so it's greater than it, right? So this inequality, let's see if it's true or not. All right, 1 over 3 times negative 0.5 plus 6, and on the right side you have 1/3. Let's see where this goes. 0 is less than 1 over, now 3 times 1.5 is going to give you, bismillah, negative 1.5, and negative 1.5 added to 6 is going to give you 4.5. So you'll have 4.5, less than 1/3. All right, now you're welcome to open up a calculator and type in 1 over 4.5 and see what you get. And you'll find that that truly is a number that's going to be between 0 and 0.333 running. Okay, so it does work. As long as x is a number that's going to be greater than -1, it's going to work. And if you take a number that's less than -1, that's not going to work. So those are some odds and ends of inequalities that you haven't seen those before, and I wanted to kind of go through them with you. Okay, now the last type of inequality, and a very, very important type of inequality that many of us will need, because when we go on to upper level mathematics, so let me write the name of it first. These are called absolute value. These are called absolute value inequalities. All right. Now, in absolute value inequalities, you need to know a few cases just so that you're comfortable with the idea. Let's suppose that I told you that the absolute value of x was greater than 5. Right? What does that really mean? Well, you need to understand what exactly absolute value does. Okay, so what you're saying is x is some number that when I take its absolute value, like, I'm going to end up with something that's greater than 5. So let's suppose that x was, I don't know, -6. Right? Let's just suppose x was -6. Well, if x was -6 and you took its absolute value, what do you get? You get 6. And is 6 greater than 5? Yes, it is. So that means -6 actually works for us, right? Well, what if x was -4? What's the absolute value of -4? The absolute value of -4 is 4. Is 4 greater than 5? No, it's not. All right? So what are we really saying? Because it looks like when you tried -6, it worked. But then when you tried -4, it didn't work. Right? So it looks like a number that is going to be less than -5 is going to work, but a number that's greater than -5 is not going to work. All right? You're welcome to pause the video and try that. Right? So on the left-hand side, what we're going to do is we're going to say -5. Right? We're going to say -5, and as long as this number that we're picking, let me just kind of move this over a little bit. Right? The number that we're picking right here, as long as it's going to be a number that is less than -5, this is going to work for us. As long as it's a number that's less than -5, this works for us. On the other end, now think about, what if you had used +6? What's the absolute value of +6? Well, it would still be 6, and that would still be greater than 5. Whereas if you had used +4, the absolute value of +4 is 4, and that is not greater than 5. So that's not true, right? So what we realize from that conversation is as long as x is a number that's going to be greater than the number 5, you're going to be in business and you can actually work with it. So altogether, what does the answer actually end up looking like? The answer ends up saying that x is either a number that's less than -5, or x is a number that's greater than 5. That's actually the answer. Right? Now we need some kind of an algebraic technique to go through that. Otherwise, it's easy to kind of lose track. So here's the method that we generally give to kids. Unfortunately, most students will only memorize the method and they don't know why the method works. And why the method works, I showed to you on the right-hand side just now. So we say case 1, all right, case 1 is x. So notice how I took off the absolute value sign. X must be greater than 5. That's case 1. And case 2, all right, so case 2 is x must be some number that is less than -5. So we do two things here. Number one, we take off the absolute value sign and we write down the same case again. All right. And then number two, we are going to change that number to a negative, which thereby is going to cause that inequality to flip around. Because remember, in inequalities, if you multiply a number by a negative, it causes the inequality to flip. So that's the scenario that we're going to use. And that's essentially the answer that you're looking at in this question above anyway. All right. So I'm going to try a number of these just to help drive that point home, inshallah. So let's start with number 92. All right. Number 92 says the absolute value of 2x is greater than 6. Well, if the absolute value of 2x is greater than 6, what we can split this up into is that means 2x must be greater than 6, and number 2, 2x must be less than -6, like that. Now, if you divide by 2 on both sides, you'll end up with, right, you can divide by 2 on both sides in both inequalities. X is greater than 3, and x is less than -3. Now, it's very important. I need to see this from you on your homework because I need to see this on a number line, right? So if you were to put this on a number line, you would end up with -3 over here, +3 over here. And what you're saying is x has to be a number that's greater than 3, so you got to shade towards the right, like this. And x has to be a number that's less than -3, so you got to shade towards the left, like this over here. And so both of these answers are represented on that number line. As long as you give me a number that's less than -3 or a number that's greater than 3, it's going to fit the inequality. Otherwise, it's not going to fit the inequality, is what I'm trying to say here. All right, let's try a handful more, inshallah, but we are wrapping up with this particular set, and then we have a few word problems, but that's pretty much going to be wrapping up the year for us. So number 96. All right, number 96 says that the absolute value of 2 minus 3x is greater than 1. All right, so it's greater than 1. And so what we can do is we can break this up into its two cases. So 2 minus 3x is greater than 1, and 2 minus 3x is less than -1. So notice the two switches that we make. We first switch that number to its negative, or whatever it was, to the opposite of it, and then we flip the sign on the inequality, whereas the first case stays exactly the same. Now when we solve both of these, we end up with -3x is greater than, 1 minus 2 is -1, right? So you bring that 2 over, and it becomes a minus. Same in this case. You can just do them simultaneously. So this becomes -3x is less than -1 minus 2, which is -3. Now, oftentimes I've gotten comments from students saying, wait a minute, I thought you're supposed to flip the sign on the inequality. You don't flip the sign on the inequality when you subtract on both sides. That's when you divide by a negative on both sides. And you want to see the previous lecture. I did a detailed part of that lecture that talks about exactly this misnomer that students have, right? Now, when you divide by -3 in both of these inequalities, notice how you are dividing by a negative, right? That's a -3 right there. So this is going to become x is less than -1/3. See how that inequality flipped? Whereas the other one makes it x is greater than +1. All right, so now let's take a look at this on the number line. Right? These make very little sense until you don't see them on a number line and you're convinced that, yeah, that actually does that actually does work, right? Sorry, I have a thing for straight lines, and then the line must be straight. Okay, all right. Now, if you're saying that x has to be a number that's less than -1/3, all right, here is -1/3, and you got to be less than that, so you got to shade towards the left of it, like this. And then x has to be greater than 1, so here is 1, and you got to shade towards the right of it. So it's, the idea is the same when it looks like when you see the graph, you know, but it's important to understand where that actually came from. Now, I just want to do a question that I think I did number 96 for you, I want to step back a little bit, and I want to try number 94 because I want to show you another kind of shading that can occur, and I was hoping to see it soon, but I didn't see it. So 2x plus 5 is less than or equal to 7. All right. So initially you're unsuspecting of this, and you're just going to go about it the same way. You know, what's the difference? So go ahead, make the two cases. I'm not saying that's wrong, but it's the shading that you kind of don't see coming. So here is the two cases, right? You flip the sign on the inequality, and you switch you basically switch the number first, and then you flip the sign on the inequality. That's the situation. Now when you solve the one on the left, you subtract 5 on both sides and you divide by 2, right? So let's just kind of expedite that. So 7 minus 5 is 2, and then divide by 2 on both sides. So you end up with x is less than or equal to 1. Whereas on the right side, you end up with x is greater than or equal to negative 1. Now, if you put this on a number line, all right, watch carefully. If you put this on a number line, the first set is saying x has to be a number that is less than or equal to 1. So I'm going to shade that, and I'm going to say that just for now, I need to shade towards the left. But then look at what the right one is saying. Just look at it carefully. It's saying no, x has to be a number that is going to be greater than or equal to 1. So it's actually saying that no, you got to be on this side of the number line, all right? And so what really ends up being the answer is the overlap of those two, where they both agree on, right? Where both of those are satisfied. So really the graphing ends up looking like what you have in front of you, okay? And the previous few questions that I did, it wasn't really bringing this part out, so I needed to kind of show you something that would. All right, number 98. So these are just, again, now these are simple, but they make them look complicated. So negative x absolute value minus absolute value of 4 is less than or equal to 2. And the reason why they write this, by the way, these are important questions just to help you understand that, listen, whenever there's an absolute value around a number, you know the answer to that. All right, you don't have to argue that. So in fact, the absolute value of 4 is simply 4, right? So here's what that looks like. Now you don't want to start flipping this into cases just yet. What you want to do is make sure that there is only an absolute value on the left side. Right? You can't do any of these cases unless there's an absolute value on the left side. So we are going to move the negative 4 over. So here's what you have. The absolute value of negative x is less than or equal to 6. Now we're going to break this into its two cases. We're saying negative x is less than or equal to 6, and we're saying negative x is greater than or equal to negative 6. Now if you solve the one on the left, notice how it's going to do something very tricky for you. When you divide by negative 1 on both sides, right, you're dividing by a negative. And the rule in inequality says whenever you divide by a negative number, it switches the direction of the inequality. So the first answer becomes x is greater than or equal to negative 6, whereas the second answer becomes x is less than or equal to negative 6. Again, without a number line, it doesn't give you too much understanding of what they're talking about. So it's, oh, sorry, I missed something. That's a positive 6, not a negative 6, right? So x is greater than or equal to negative 6. Here's negative 6, all right? And you're going to go ahead and shade that. And you're going to say everything towards the right of negative 6. The other one says x is less than or equal to positive 6. And so you're going to shade this, and you're saying it's everything to the left of. Again, they have to come to an agreement, and the agreement that they come to is it must be the middle that actually works out for us. All right? So it's basically the overlap. And finally, the last one that we have on this set, and rightfully so, is number 100. Number 100 says that the absolute value of negative x minus 2 is greater than or equal to 1. All right, so let's split this up into its two cases. Negative x minus 2 is greater than or equal to 1, and then negative x minus 2 is less than or equal to negative 1. In that first situation, if you move the negative 2 over to the right side, you're going to end up with negative x is greater than or equal to 3, and the other one is going to be negative x is less than or equal to, let's be on the positive, so 1, right? Because 2 minus 1 is 1. And then when you divide by negative 1 on both sides, in that first situation, you end up with the answer x is less than or equal to negative 3, like that. And the other one becomes x is greater than or equal to negative 1, like that over there, all right? Again, on a number line, right? So I'm doing all these hard problems on a number line. Negative 3, you're going to be less than that. So let's pull negative 3 and negative 1. So here's negative 1, here's negative 3. We're just kind of looking at the left side of the number line there. So if x is a number that's less than or equal to negative 3, it's got to be this way, all right? And if x is a number that's greater than or equal to negative 1, it's going to be the other way, like that. And so one conclusion that I want you to come to eventually is basically here's the case. Whenever you have an absolute value of anything, and it's going to be a number that's greater than or equal to some other number, okay, let's just call that number k, all right, let's just suppose you're always going to find, all right, what's most important here, by the way, is the absolute value and the fact that it's greater than or equal to. That's what's really important. That's why I left everything out, all right? You're always going to find that you're going to end up with two numbers, all right? And every single time, you're always going to end up shading outwards, like this. All right, this is just a really good way to make sure that you're doing this correctly. And if you start up with a case where it is less than, all right, so less than or equal to k, then you're going to find that it's actually inwards. And you can go back and you can check all the questions that we've done, right? Check me on this, and you'll find that it's going to be between. Now, technically, that's shaded circles, right? But the whole point is just for you to realize that when it's less than or equal to, it leads to that between situation, whereas if it's greater than or equal to, it leads to that situation that you saw earlier. All right, number 106 is an application question, and it says, what is the domain of the variable in the expression? So if you've got a square root of some number, right? Let's suppose that it was the square root of 9. What's the square root of 9? It's 3. What's the square root of 4? It's 2. What's the square root of negative 4? You have an error. You can put it in a calculator. It'll say error, right? So it's not equal to error, but it's an error. If you find the square root of any negative number, you will get an error, right? You can't get a real answer. All the way at the end of pre-calculus, you learn what that answer was, though. But for now, basically what we're saying is the number inside of this parenthesis, inside of this square root, always has to be a number that is greater than, all right, greater than or equal to 0. And the reason why it can be equal to 0 is because, let me ask you this, what's the square root of 0? The square root of 0 is 0, all right? So that does work for you. And so that's the logic and the reason why we say, well, if that says 8 plus 2x, then we have to write down 8 plus 2x has to be greater than or equal to 0, like that. And then you can solve it. 2x is greater than or equal to negative 8, and therefore x has to be a number that is greater than or equal to negative 4. So that's how you solve number 106. All right? It's the logic that's important. Middle-aged men may be defined as being 40 or more and less than 60. Okay, so if you're a middle-aged man, you're 40 or more and less than 60. It says express the statement using inequalities. So one of the ways that you could say this is you can put an x in the middle, and you can put inequalities like this and write down 40 and 60. Now, if you're wondering why did you put an equal sign on one of them, it's because it says you can be 40 or more, right? So you can be equal to 40, right? X can equal 40, but it can also be greater than 40. But then there is a limitation, right? There's a limitation, and the limitation is that you got to be less than 60. So this is what middle-aged is called, by the way. All right, so that less than 60, notice how it doesn't say equal to 60. And because of that, here is your statement that you've got.